Okay, I hope we are back live. I've had some sound. I started out with sound. Actually, started out, and we were disconnected. I just assumed something happened with the internet. Um, Although I maintained continuous contact with the laptops, so it couldn't have been the internet. Um it had to be a YouTube thing or my streaming software. But whatever, I am back now, and we are live on YouTube. I don't know if this is a second video or if it's adding just more information data to the original one. But regardless, I'm going to continue the imaging session. So let's go and share the screen, and I'll show you what we've been doing while while you were gone. I went ahead and, of course, I started PowerBox. I connected all the gear. I used the ASCOM driver to connect my hand controller, just like I did with the other kit. And then I started the cooling, clicked on all of this gear. We activated the Pegasus observing. Uh, when we look at our settings in the Pegasus Powerbox, uh, it's also showing 99%, but it almost always does when you first connect the gear. We have a temperature of 75 degrees, and that's consistent with the other Pegasus. That's pretty good sensors. They do a pretty good job. Okay. Uh, we've got PEHD started, and what we need to do now is to slew to the part of the sky. I'm going to go ahead and start looping, although we're still aimed north. We need to activate our outside camera so we can see that nothing crazy happens when we slew. And let's go ahead and do that now. So we're going to slew to 1396. And here we go. You don't have to go far. And we're going to center. And of course, this is the plate solving where an image of the sky is taken by the imaging camera. It's compared to a database from those RA and DEC coordinates. That database has the precise location, and it will match the stars in my picture with their stars and move the mount to center it. In our first attempt, we were 171 pixels off in RA, and we're 31 pixels off in DEC. The second run, we're off 7 pixels, but it's 4 in RA and 6 in DEC. We're good. So let's go ahead and click on run the sequence. And it's going to, oh, we haven't set up an imaging session. We can't run a sequence. We're going to take HA03S2. Now, the difference between this telescope and the Vixen is this is with the reducer, this is at f4.6. And so we're going to get by with 180 second exposures, and we'll try to get by with 40 of those. 1.8, 40, 1.8, 40, and I'm going to set the gain to 200. I'm at unity gain on the Vixen and 50 offset. All right, let's go ahead and start our guiding just to make sure. We'll go stars, start guiding. I probably could have calibrated since it's been a month seems like a month of Sundays since I last started imaging. And anytime I have guiding errors, I usually just stop and recalibrate my mount. That almost always improves it. Doesn't always solve everything, but it usually improves guiding. We're under 100 right now. Total RMS 91, not great. We're over 100, but we're such a wide field. We get by with pitiful guiding at times. You can only go so far though, but I also know that it takes 5 to 10 minutes of guiding for everything kind of get worked out before it settles down. So we want to go on back and start the sequence and let the software start. It's telling me we haven't cooled enough, and I understand. We're going to delay the start until it has. I'll tell you what, let's go ahead and do a focus, get that out of the way. And you may have already picked up on the focusing routine, that it takes 4 to 5 minutes to run it. And when you have temperatures that drop in the night 10 or 15 degrees, that thermal effect on the telescope can really be significant. And what were in focus pictures can end up being focus problem pictures. So it's a good idea, and it took my hard head a long time to accept it, but it's a good idea to refocus after every at least 2-degree temperature drop. There are a number of imagers that are going to refocus after every 1-degree imaging drop. But I've set my systems up to do a refocus when the temperature drops 2 degrees, and also to refocus on every filter change, since my filters are not parfocal. I have to. We're going to be doing this routine. It's going to take a few minutes. It should have stopped the guiding while we're doing this. It didn't. I may not have this set up to do that, which is okay. It'll give the guiding a chance to work out some of its kinks and kind of get a good rhythm going. But let's go back to our other telescope, and let's see where we are in this routine. I'm going to look at, we have taken 5 images at 240 seconds. Our stars are looking pretty tight. Our half flux radius is at 2. It's at 2.27 on this image. If we go to the prior image, it's 2.32, 2.38, 2.4, 2.27. I guess we're going to be around the 2.2s until we refocus. And we will refocus when there is a 2% temperature change. Here's how I control that. I go to my control panel, I go to focus, and use settings, and ooh, I don't have it set up. Autofocus every, that's right, we entered all these in a new, okay. Autofocus every 2 degrees, on autofocus on every filter change. So when there's a 2-degree change, we'll run the autofocus routine, and we will, of course, autofocus after every filter change. So that's good. That's what we want. But it adds time to your routine. Right now it says we're going to need 5 hours and 35 minutes to take all of these pictures. It is 11 o'clock. And what time did we say it was going to transit? 3 something. So let's go and double check transit time. We can go down here to planning tools. Transit's at 3:05. So we've got 4 hours of imaging time. We're going to be taking too many pictures. So let's take 30 in HA, 20 in, let's say 20 in S2, and let's see how much time we're going to be using now. We're still at 4 hours and 15 minutes. Let's just knock them both down, all of them down to 20. If we can image tomorrow night, we'll add another 20, 20, 20. So we have 4 hours, and roughly that's what we have left. I doubt we'll get them all in, because when you add the focusing time to this time and the dither time, because I dither after every image, and that adds another 15 seconds. And so you're going to take 60 images times 15 seconds. So you're going to add a few more minutes to the equation. So focusing times, imaging, dithering, we probably need 5 hours of sky time in order to do 4 hours of imaging time. So it's probably going to go ahead and flip the mount in order to do that. So let's don't worry about it. I tell you what, it's going to be 3 o'clock in the morning. We probably can go to 4:30. Let's make it 25 and go ahead and flip. Not worry about transit. So we're going to take 25 apiece, and that should take us to about the 5 o'clock time. And honestly, you start seeing some of the sun's light in the east, and of course we're going to be in the we're just going to have crossed the northern meridian, so we'll be influenced by that. If we go to 5:30, definitely we'll have some new light to deal with. So let's go ahead and let's try to do 25 each. I know we'll get 25 HA and 25 O3 if we don't have clouds. And then let's instruct the mount. Let's click here to park the telescope when it finishes taking the S2 images. And once it finishes, it will shut down the camera, the filter wheel, the focuser, the mount. It will shut down PHD2 and disconnect that equipment. So everything will be turned off, with the exception that the power box will still regulate the dew heaters if they're needed. Right now, they have both dew heaters turned on, because they're still saying that the relative humidity, I'll check it with the weather station, my weather app, it still says the relative humidity is close to 100%. It may be. It's hot outside. Not as hot as it was. All right, I'm assuming we're still live. And I'm assuming the sound is better and not echoing. Let's go now back to our other telescope. And we finished the routine, and we're taking our first image. And we're going to hide our sequencer so we can see what the first image looks like. By the way, this is, I elect to look at the PhD graph. And the PhD graph is showing me, we're probably around I don't know what we're around. Let's look at it. We're at 102. That's okay. That's okay for this wide field. All right, let's go back to our image. And there we do have some of the elephant trunk. And let's stretch it a little bit more. And you can see that circle of nebulosity that's in the plate solve there. And so we're on our way. We're taking HA. There's our filter. Our focus point has been set to 10,936 steps out. So the focuser is racked out 10,936 steps. And of course, it's monitoring in Celsius. It's monitoring the temperature. And it's telling me that since the last focus attempt, it's actually gone up. No matter where it goes, it's got to, if it's 2 degrees, then it's going to refocus. Life in the South. All right, we'll bring our sequencer back. We've got one of 40 pictures, 5 hours and 55. I'm just going to let it run. I want to set this to park when it's done. Okay. I hadn't set the gain, but I want the gain to be at 139. And that's what it should be up there. And 20 unity. And that's what it should be. I'm pretty sure it is. We can go ahead and put the surveillance cameras to sleep. And folks, we have 2 telescopes imaging the same target, one with a 336 millimeter field of view, and that's this one. And we have one with a 625 millimeter field of view, and that's the Vixen. And that's this one. This is has the appearance of being closer to the target, and it is. This has a almost a 7 focal ratio, opposed to a 4.6 focal ratio for the stellar view. So I'm having to take longer exposures to get the same data, and I actually am not getting the same data. This is a fainter signal, but this is the elephant trunk centered that we're looking at. So if the skies remain clear, when I wake up in the morning, we should have 2 flipped mounts that have completed their imaging sessions. It should be I would say we'll probably have to make some adjustments to the number of images we're going to take, because this one will be okay, or should be, but this is 6 hours, and we don't have 6 hours of imaging time. So I'm going to knock this down to 30, this down to 30, and this down to 30. And now we're at 422. We should be able to get that in. But the transit is essentially going to apply. We're going to go ahead and I'll show you what I do. I'll go to my control and I go to telescope and I check use auto meridian to flip. Now, if you're using EQ ASCOM and you're running with this hand controller, EQ ASCOM will give you this. If this is what you're using, you have got to disable the let's see, that's going to be under mount limits. You cannot have auto meridian flip checked. This cannot control the flip. Sequence Generator Pro must control the flip. You'll have nothing will happen and you'll wonder why. So make sure that if you're using EQ ASCOM that you set your flip up here, and then you can tell the mount to wait if you want. If you think that your mount can continue in the direction where the weights get higher than the telescope, and you're not afraid of your telescope running into your tripod, then you can elect not to have the flip happen maybe an hour, 60 minutes past the meridian. But I just go ahead and tell it to wait for the meridian and flip. And then I want it to auto center. In other words, do another plate solve and then auto center and resume imaging. So the reason why mounts have to flip is we'll have to go outside for this. No, we don't have to go outside. It'd be better to probably use, would it be better to use, yeah, let's go outside. I'm going to bring up the surveillance camera and activate it. Okay. As the night goes on, this camera, this telescope is going to start moving this way, and the weights are going to start moving up. And at the meridian, the weights are at the same height as the telescope. And if you did nothing, the weights would continue to go up and the telescope might go down, and in this case, hit my laptops. And damage can be caused. So what we instruct the telescope to do is flip. And so the telescope will then do a complete flip this way, and the weights will be on this side, and the telescope will be on this side, and it'll be going up this way, and the weights will be going down as it tracks the same target, centered on the same target as it tracks it on the other side of the meridian. The meridian is kind of an indivisible line that splits the sky at the north. If you look directly north and just imagine a line running through the sky all the way to the south, you have the southern meridian and you have the northern meridian. It's the same line just traversing the sky. And if you're in the south, you have to flip. If you're in the north, you have to flip. So that's the nature of keeping your telescopes protected and from banging into stuff. And when you have tripods where the leg sticks out, then it becomes easy for your telescope to connect to your tripod leg. And there's been a lot of permanent damage done. So we're going to be doing flips tonight. in order to get 90 images for the stellar view, and I think 60 images for the no 75 images for the Vixen. We had a meteor. We had several meteors. Here comes one here, and here comes one here. They differ from airplanes. They're a pain in the you-know-what, though. Those can easily be calibrated out, but airplanes sometimes are, depending on how close they are, their trails are so obnoxious. They're kind of sometimes hard to calibrate out, but at any rate. Okay, folks, I see no reason to continue. We could just continue to watch images come in. And right now we're at 9 images coming in HA, but it will be a good while before we switch filters. And we have 4 images that have come in on the stellar view side in HA. Yep. Okay, guys. With that, we'll catch you on the well, next time we go live. But or we upload a video. But I'm going to try to image this again tomorrow night, and if I do, I'll more than likely do it live. Again, it depends on the skies. So clear skies in your neck of the woods. This is the Night Sky Imager, bidding everybody a great rest of the week.